Well, hello everybody and welcome. This is the first video that we're doing for this class out of, I don't know how many, just depends on what I think that we need as we move through the semester. So I'm sure you remember, since it's due today, it was only last week that you worked on the analyzing the strips in the 50 strip practice packet. So each one of you had 10 strips that you were supposed to analyze and put into a table for your group. So I spent some time this afternoon compiling all of those strips, and it is obvious to me that we have quite a bit of variation in how strips are being measured. So I do want to spend a little bit of time going over best practices for EKG measurement and hopefully correct some of the issues. I also suspect that the other part of it has to do with trying to do the measurements on the computer screen rather than printing it out. So if you have the opportunity to print out your 50 strip packet, I highly recommend it, simply because it's much easier to measure strips that are in front of you on paper. So without further ado, let's take a look at some EKG best practices for measurement. So this list is a little bit different than what I asked you to do on this first assignment, but it's the same basic principles, and I'm going to add to a little bit based on what we've done before. So one of the big mistakes that I see students make when they are trying to interpret an EKG rhythm strip is just trying to eyeball it and recognize the rhythm. They want to jump straight ahead to identifying the rhythm without doing the measurements. There are some rhythms that you can do that with, and we're going to see that when we get down into lethal ventricular rhythms. But there's also a whole lot of rhythms that you are going to miss if you just try to eyeball and recognize what you think it's going to look like. So just like if you played a sport and you had to do drills, or if you played an instrument and you had to learn to play scales, we're going to go back to the basics of how to measure. And one of the most important principles about measuring is to have a set way that you go through and analyze every strip. And so I'm going to share with you my basic analysis that I go through on every strip, and hopefully that will help you. So the first thing I always look at is the rhythm. And I don't mean the rhythm interpretation. I mean, is it regular or is it irregular? Sometimes you can really see it pretty obviously if a ventricular rhythm is irregular, but it's not always as easy to see if the atrial part of the cycle is irregular. So the way to figure out if something is regular or irregular is to count between like waves. So you want to measure P to P all the way across the strip. You want to measure R to R all the way across the strip. And if those come at a predictable time, then you know that it's regular. So remember, anytime you're looking at an EKG strip, as you're moving across, what you're really looking at is time. So if there is the same amount of distance between two like waves and the next set of like waves, then that took the same amount of time for that part of the cardiac cycle to happen. And I'm going to show that to you a little bit more in a second with a very dramatic drawing. It's going to change your life. So the next thing that I like to look at is the rate. So most of the time when we are looking at EKG rhythm strips, the easiest way to look at it is in 6-second strips. Now, not all of the strips that are in your practice packet are actually 6-second strips, but on a lot of them, you're going to see some darker hash marks. When you see darker hash marks, between those two hash marks are 3 seconds. So 2 sets of those are 6 seconds apart. So you might be thinking, well, 6 is an oddly specific number of seconds to want on the strip. Well, that's actually strategic. There are 60 seconds in a minute. Therefore, if I look at a 6-second strip and start counting, I can just add a 0 to the end of my count to figure out what the rate is for the whole minute. For example, if there are 10 QRSs on my strip and it's a 6-second strip, then I know the heart rate is around 100. You'll see what I mean in a minute. But it is also important to look at the rate and the rhythm of your atrial contractions or atrial impulses as well. We'll talk about that. The way that you look at atrial stuff is by looking at the P waves. So here comes the drawing. You're going to be very excited. This is big business. So this is a heart. You're just going to have to believe me. And the heart is in 4 chambers. In the SA node, where most impulses are supposed to start, the cardiac cycle should start there. We're about to discover that in a lot of atrial dysrhythmias, it doesn't, but that's where it's supposed to start. So when the SA node fires to start the sequence of electrical impulses that triggers the heart to beat, that is evidence that the P wave is involved. So when this depolarizes, you get a P wave on the EKG. As it moves down the heart, somewhere around the AV junction, we have the AV node, and then it branches off into the Purkinje fibers, innervating the ventricles. So P wave indicates there has been some activity here in the atria. Typically from the SA node, we're going to see some exceptions to that. How the impulse should travel is down through the AV node and out to the fibers, okay? When we measure the P to R interval, we're trying to see the distance between here and here. Well, why do I care about that? The QRS is the measurement of how long it takes to get from here all the way out to here. So the QRS is measuring this ventricular part, okay? The PR interval is measuring how long it takes to get from here to here through the AV node. That may not be terribly important right now, but when we get to AV blocks, it's going to be extraordinarily important, and you're going to hear me talk about it again. So basically, I'm using this PPR-QRS business to get down to how long it's taking from the time the impulse starts to the time the impulse finishes. Okay? More on that soon. Let's do a little bit of practice, and we're going to add even a couple of more measurements to it. So one of the things that I can tell from some of the measurements that I saw is that we are not all following best practices for where to measure our distances. So by way of review, when we are looking at distance here, you can see these big, heavy boxes. Each one of those is 0.2 seconds long. Each one of these big boxes has little boxes in it. Those are each 0.04 seconds. So 5 of those is 0.2. So small and large. When we are measuring tracings on this tracing paper, it's super important to measure along what we call the isoelectric line. Now, sometimes it's real easy to see the isoelectric line, and sometimes it's harder, and we're going to see that toward the end of the semester. But basically, there's a baseline, just like when you were learning how to do handwriting, you had to keep going back to the baseline. We are going to be looking at the baseline of our strips too. So can you see that this baseline is pretty much where everything comes back? That's going to be the isoelectric line. So when I measure beats and distances and stuff, I want to be measuring along the isoelectric line. So more on that in a second. A little bit about the tools we're going to use. I have a Mr. Pencil here. My pencil is my handy dandy pal. You can use a pen, whatever makes you happy. I have my calipers with me. Calipers are a nice thing to have if you read a lot of strips, but I'm going to tell you the truth, even though I've had these calipers for almost 30 years and I use them all throughout my practice, I can manage just as effectively with a piece of paper. So I'm going to show you both methods. I'm going to use my calipers this time, and I'll use my paper on the next strip so that I can show you what to do with that. So I'm just going to go down the line here, and we're going to practice some good interpretation methods on this practice strip. So the first thing that it's asking me here is the atrial rate and the atrial rhythm. And remember, I'm not looking for a rhythm interpretation. I just want to know regular or irregular here. So atrial rate. Well, the atrial rate, the only thing that I can count on an EKG that tells me anything about what the atria are doing is the P wave. Now, it's really important to remember that the P wave does not really represent a ventricular contraction. It represents the electrical wave that should result in a contraction. So when you are looking at this business on here, you're not looking at heartbeats. You're looking at electrical impulses that should result in a heartbeat. More about that later in the semester. But that's just an important distinction to remember, that you're only looking at the electrical activity, not to the mechanical activity of the heart. So my task is to figure out where the P waves are. So they do it alphabetically and in order for a reason. And isn't that nice of them? I don't know why they started with P, but we've got P, Q, R, S, T. So a P wave, this is lead 2. Lead 2 is where most of our interpretation is going to come from, because everything's nice and upright and above the line, and we like that view of the heart for easier interpretation. So in a normal rhythm, I should see P before the QRS. It should be upright. Then I'm going to see a QRS and then a T. So the P represents that SA node firing, depolarizing. I'm going to follow that down through the QRS is where it's depolarizing in the ventricles. The distance between P and R is this PR interval. How long is it going to take to get through the AV node? And then the T represents repolarization of the ventricle. So the atria repolarize as well. It's just that activity is buried under the QRS and you can't see it. No big deal. We don't need to see it. So I can see pretty easily that there is a little bump before each QRS that looks roughly the same. So my first task, this is a 6-second strip or pretty close to it. So I'm just going to count how many P waves I've got on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got an atria rate of about 120. Okay? I should not just look at the strip and eyeball it and try to decide if I think it's regular or irregular. Best practice is going to be to measure it. So in this case, I'm going to use my calipers, and I'm trying to make sure that you can see this here. I want to start, I'm going to plant my calipers at the beginning of the P wave and go to the beginning of the next P wave. So you don't want to count P waves from the tallest peak. You want to count P waves from the beginning of one impulse to the beginning of the next impulse on the isoelectric line. I think that that's a big mistake that people probably made on the initial assignment, and that's okay. You are here to learn from mistakes, and I, on purpose, didn't give you much teaching ahead of time just to see where we were at. So, beginning of the P to beginning of the next P, and then I want to start going across to see if they come in roughly the same place. And I can see that these are a little bit different. They're a little bit different, but they are pretty close to the same. So we could tolerate a little bit of difference, but I can see that the next P wave comes where I expect it to show up. And real life rhythms are never perfectly neat and clean, but I'm going to say that's 120 and regular. Would you say that's normal or abnormal? Well, regular, that's normal, but 120 seems pretty fast to me. So I'm going to say it's abnormal because the rate is pretty high. Okay. Now it's time to look at the ventricular rate and rhythm. So same deal. I'm going to count the R waves. So the R is the in lead 2 is the first upward deflection from the baseline after the P. Most QRSs don't have a Q. We'll talk about that later in the semester. Don't worry about it. It's still called QRS. But I can see that these tall spikes are the QRSs. I'm going to count the R waves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I also got about 120 for the ventricular rate. Here's a little hint. If you have 1 P for every QRS on the strip, this should be the same. Okay? Now, I can eyeball this and think, well, that looks pretty regular to me, but best practice is going to be to measure it instead. So here, because that R wave is so spiky on the top, it is easier to just measure the peak of the R wave all the way across the strip. Do you see that they are the same distance apart? I can see that those R waves are coming exactly when I expect them to. So I know that this is regular. But for the same reason, I'm going to say that this is an abnormal finding because that rate's just a little bit too high. Now it's time to do our PR interval, our screening test for problems through the AV junction. This is something you should always be in the habit of doing. So I'm just going to find something kind of in the middle because it's easier to do. So again, if we are trying to measure how long it takes for the impulse to start here in the SA node and to get just through the AV junction to where it starts the ventricular depolarization, then I need to measure from the beginning of the P to the beginning of the R along the isoelectric line. So where the P wave rises up off the baseline, where the R wave rises up along the baseline. And there's a couple of things I want to know about this PR interval. Number one, is it consistent all the way across the strip? And then secondly, I want to know how long did it take. So I'm going to measure, and I am just kind of putting my calipers on that R wave and seeing, does it look about the same from beginning of the P to the beginning of the R all the way across this strip? And it does to me. It looks regular. Now my task is to figure out how wide it is. So I find it easier to figure out the width either with the calipers or my paper, and I'll show you that on the next strip. And I bring it down to these boxes down below. So if I put my caliper on the beginning of one box, I can see how many small boxes it is easier, okay? I can see that I've got right about 4 little boxes. So 4 little boxes is 0.16 seconds, and it's regular. A PR interval should be less than 1 large box, or 0.20. So this is less than 0.20. It is regular. That interval is regular all the way across the strip, so that is completely normal. So I know that activity through the AV junction is just fine. It's getting through that node okay. Now it's time to look at the QRSs. So I want to know how long it takes for the ventricles to depolarize. So for the ventricles to depolarize, I'm going to measure from the beginning of the R. And if there was a Q, you would do that too. And you can see just lead placement. I'm looking for one that's a little easier to see. So where the R rises up off the baseline to where the S comes back to the baseline. So this is the R, the upward deflection after the P. The S is where it comes back down below the baseline, and where the S comes back to the baseline is where I want to measure. And I'm going to start measuring them all the way across this strip and see if I've got the same. A little hard to see on this one. Some of them are easier than others, but I can see that they appear to be the same length, the same width all the way across the strip, roughly. And I can see that that width is about 2 small boxes. 2 small boxes is 0.08 seconds. I know that it's regular because it's the same all the way across the strip. I'm going to say that's normal. A QRS should be less than 0.12, or 3 small boxes. If it's wider than that, if it's wider than 0.12, then I know the signal that generated that QRS came from the AV junction or lower. It couldn't have come from the atria because it's too thin. Okay, so that's something that we're going to come back to in a little while. So another thing that we didn't really talk about in our first slide, but you had to do in your practice, was the QT interval. So basically, how long the ventricle takes to recover and be ready to beat again. So you go from the beginning of the QRS, which in this case is the R, to the beginning of the T. Beginning of the Q to beginning of the T, where the T rises up off the baseline, because the Q represents depolarization, or in this case the R, and the T represents repolarization. I want to look and see, is that the same all the way across this strip? And from everything I'm looking at, the answer is yes. So now I'm just going to bring it back down here, back to the boxes, and see how long that took. And I'm seeing 1 large box, or 5 small boxes. That's 0.20 seconds. And that's within the tolerance of normal. When we get to ventricular dysrhythmias, we're going to talk about why that QT interval is so important. But for now, we're just going to practice measuring it and keeping it in our minds as something that we want to look at. We are screening for problems. Okay, so far I am seeing what looks like a fairly normal rhythm. I've got evidence of sinoatrial node activity, so it's a sinus rhythm. Okay, I'm seeing that the PR is normal, the QRS is a normal width, and the QT interval looks okay. The only thing that seems to be wrong is that the rate is a little bit fast. So if you have a rhythm that is completely normal except for the rate being too high, that's called sinus tachycardia. There are other kinds of atrial tachycardias, and we're going to talk about those, but you're not going to see those uniform and regular normal-looking P waves in those, because in those, the SA node is not in charge anymore. And when the SA node abdicates its position as the leader of the electrical impulse, then crazy things start to happen. You start to get atrial anarchy. We're going to talk about that. I know I keep saying that, but we really are. So one more practice and this video is going to be done. So here we are looking at a copy of an actual EKG strip. You can see all the pre-printed stuff on here. You can see these lines at the bottom. This is actually just, it's probably a blood pressure tracing. You can see the scale here from an atrial line. So we are going to ignore this line here at the bottom, and we are going to focus on the EKG tracing that is at the top. So we're going to go through exactly the same steps that we did with the first one, only this time I'm going to use my paper to show you how to effectively use paper to do exactly the same things. So I want to start with an atrial rate and rhythm. So this is a 6-second strip, or pretty close to it. So I'm just going to count the atrial rate by looking for P waves. So I can see a little bump before every QRS that looks about the same, and those are P waves. So I'm just going to count how many times the SA node fired in this 1 minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And almost another one. So it's probably around 100 or a little bit more. I'm just going to go with 100. We know it's close. We're just estimating. And to figure out if the rhythm is regular or irregular, I'm going to take my paper and I'm going to lay it along the isoelectric line. I'm going to measure the P wave where it comes off of the baseline, and the next P wave where it comes across. I'm going to make that a little bit bigger so you can see it. And then I'm going to start scooting that along, beginning to beginning, and see if it comes in a predictable fashion. This is one way that it's really helpful. If you're seeing little bumps that you aren't sure if they're P waves or not, you can start measuring out some waves that look the same and see if they're equidistant. If so, they probably are P waves, because the SA node is pretty good about firing uniformly at a uniform rate. Again, there are possibilities like sinus arrhythmia, in which the SA node speeds up and slows down based on changes in interthoracic pressure with the respiratory cycle, but most of the time the SA node is going to fire pretty uniformly. So this is a good screening tool. So I'm seeing these P waves coming at uniform intervals. They're coming when I expect them to come, measuring P to P from the start of the P to the beginning of the P. So I'm going to go regular. I'm going to do the same with the ventricular rate. I'm going to count my R waves because we've got a 6-second strip. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got about the same here. Since it's a 6-second strip, I can just take 10 and add a 0. And now I want to see if they are regular. So I'm just going to pick a different part of my paper here, or I'm going to reuse this line and measure to the top of the R to the top of another R, and I'm just going to slide it down my strip, and I can see that those lines line up all the way across that strip. So I know that this is regular. So we're probably a little bit over 100, so I think we've got the same thing that we had before, in that the rate was a little bit high. But otherwise, the rest of it looks okay. So let's take a look at that PR interval. I'm going to turn my paper this time set my paper along the isoelectric line, measure from the P to where the R comes off the baseline. I'm going to take that all the way down the strip. Can you see? In a way, it's almost even easier to see this when you measure with paper because those lines start to line up. And I am seeing the same PR interval, the same beginning of the P to beginning of the R, all the way across that strip. So I'm going to take my two lines and pull them down here to where I can hold it up against the beginning of one of these big boxes. It's just easier to see, and I can see 1, 2, 3 little small boxes. So 3 little small boxes is 0.12 seconds. We always want to record intervals in seconds. You don't write down 3 boxes, or you don't write down a rate. You write down how many seconds that interval was. So 0.12 seconds, and it's regular, is completely normal. We want it to be less than 0.20. So now we'll do the same with our QRS. So I'm just going to find one that looks good. The beginning of the R to where the S comes back up to the baseline. And I'm going all the way across. And I'm seeing the same thing over and over and over with only just tiny little variations. And I bring it down here and line up that left one with the beginning of this big box. I can see it's 1, 2 boxes. So 0.08 seconds is 2 small boxes is 0.04 times 2, 0.08 seconds. And I can see that is completely uniform across the strip. So I'm going to go regular, and that's a normal finding. Now, one last thing we're going to look at is our QT interval. Now, you can see this one's a little bit harder to see because it's probably lead placement. But this one is a little bit up off of the isoelectric line, but I still want to measure along the isoelectric line. You don't want to tilt. You don't tilt like this. You always measure along the isoelectric line. So I'm going Q to where the T rises up off the baseline. And that's looking about the same to me all the way across this strip with every one. So I'm going to bring it down here and same thing again. I've got about 3.5 boxes. So I'm going to say it's 0.14 seconds. It's regular, and that's pretty normal. So we actually have 2 strips with the same interpretation. I know it is a sinus rhythm because I see evidence of sinus activity. Uniform P waves, there's only one of them. They fall at an equal distance before every QRS, so I know it is sinus something. If it was between 60 and 100, it would be normal sinus rhythm. But because it's a little bit over, I'm going to say again, we've got a sinus tachycardia. The sinus tachycardia doesn't necessarily mean something grave is wrong. It might just mean somebody scared you or you walked up the stairs. And there's lots of reasons why heart rate increases. You have to think about it in context of what's happening with your patient to know whether it's a problem or not a problem. So that is a brief overview of best practices for how to measure EKGs. You're going to see us do this over and over and over. But I hope that little bit of a tutorial will help you in your group's activity this week as you move to clean up all of our 50 strip measurements. Until next time, thanks.